All right, so today we're going to be talking about Chapter 7, Lesson 4. This is Properties of Similar Polygons. So just like in Lesson 1, when we talked about congruent figures and what we need to make sure that things are congruent, similar figures also have some statements that we need to make. So the first thing that we need to do is let's look at the symbol. So the symbol for saying that two things are similar is that. Now, if you recall, this is what the congruent symbol looked like if we had an equal sign underneath it. The only difference is we don't have the equal sign here. So, same thing as before, we have to look at corresponding parts. And again, it's angles and sides. So, angles is going to be the best way to start first. And the main reason for that is because we don't know necessarily which sides are going to be corresponding, simply because they're going to be different lengths. But if you notice here, A and X both have one line to describe that angle, which means those two angles are corresponding. So when we start talking about similar figures, the angles, let's put this down, angles, corresponding angles are congruent, which means these are going to be the same symbols as before. Angle B here has two, and so does angle Y. So we'll have angle B is congruent to angle Y. And C has three, and so does Z. So we'll say angle C is congruent to angle Z. Now, when we start talking about corresponding sides, in congruent figures, those are also congruent. But in similar figures, so corresponding sides, they are proportional. What that means is this side here, AB, and XY form the same proportion that BC and YZ does, as the same proportion as AC and XZ. So the way that we write this is going to be AB over XY is equal to BC over YZ is equal to CA, or you could say AC, doesn't matter. But whichever way you choose, remember, C up here corresponds with Z, so Z has to go first. And that would be our similarity statements. So, example 1. First thing we want to do is determine if these two triangles are similar, and then, of course, explain. So first thing we want to look at is angles. So here we have a right angle, and here we have a right angle. So we'd say that angle D is congruent to angle H. E up here has 2 marks, so does J, which means we'll say that angle E is congruent to angle J. We don't even need to know what those angles are, as long as we know that they have the same number of lines. And then the last set would be F, which has 1, and K, which has 1. So you'd say that angle F is congruent to angle K. Next thing we need to do is start looking at corresponding sides. Now, it doesn't matter which way we start with. I like to go from bigger to smaller, or generally from right to left. You can start from left to right. Just make sure that you are consistent. So let's go here. We have 5 and 4. Those two sides are corresponding because they're between the same corresponding angles. So here's a right angle and the angle with 2 marks. Here's the right angle and the angle with 2 marks. So these two sides are corresponding. So we'd say 5 to 4, which happens to be 1.25. We want to find out if this side and this side form the same ratio. So let's go 6.25 divided by 5. And it just so happens that these two here also give me 1.25. And then the last one we want to check is here. So we want to see if 3.75 divided by 3 is also the same. And it turns out that it is. So we would say that 5 over 4 is equal to 6.25 over 5, which is equal to 3.75 over 3. So yes, these two are similar because, and the things we're going to be looking for are going to be these two statements here. So we would say because corresponding angles are congruent, and this is a big and, they both need to be true, and corresponding sides are proportional. Now, we talked on lesson 1 and lesson 2 about congruence. If the ratio that these corresponding sides forms happens to be 1, then the two shapes are congruent. All right, let's talk about finding missing measures. So if we know that two figures are similar, we know that their angles are congruent, corresponding angles, and we also know that the corresponding sides are proportional. So we could create a proportion to find a missing side length. So it says rectangle LMNO is similar to rectangle GHIJ, and these are the two rectangles here. So these two are similar. Letter A, it says describe the transformations to map the small one onto the big one. So what we need to talk about here is how can we get this onto this? So first thing, we need to move them over. So we would say a translation to the right. And we can't say how many units are because we don't know how far away these two figures are from each other. And because they're not the same size, we want to get them to be the same size. The only kind of transformation that we can use would be a dilation. So followed by dilation. Now we need to find the scale factor. So we need to find the scale factor. So in order to find the scale factor, we have to take this 3 and this 2, because those are corresponding sides. They're both the shorter side on their rectangle, and we need to divide them. Because we're going from small to big, that means our number needs to be a big number, or it needs to be a number bigger than 1, our scale factor. But what we're always going to do is we're going to take our image. This is just like when we talked about dilations, finding the scale factor in lesson 4 from chapter 6. Take our image, divide it by our pre-image. So we're going to go 3 divided by 2, and that's 1.5. So our scale factor, you could either say it's 3 over 2, or leave it as a mixed number as 1.5, or write it as a decimal. Now, letter B, it says find the missing measure. There's two different ways that we can do this. The first way is write a proportion. proportion. And when we write a proportion, we want to go same to same is equal to same to same. So we would say 2 to 3 is equal to 4 to m. And then we solve this by doing cross products. So we would do 3 times 4, which is 12. 2 times m, which is 2m. And in order for this to be proportional, these two need to be the same. So we would set 2m equal to 12. That's a pretty simple one-step equation. We divide both sides by 2, and our missing measure would be 6. The other way that we could do it is use the scale factor. So in order to use the scale factor, we would take the part that corresponds to our missing measure, and that happens to be this side, because it corresponds with this side. They're both the longest. So I have 4. And we're going to multiply that by the scale factor. So our m, our missing measure, is still going to be 6. All right, so that is the end of lesson 4. If you have any questions, please let me know.